Imagine Earth before dinosaurs, a world so alien it would be almost unrecognizable to us today. Picture a planet in its infancy, wild and untamed, where the very ground beneath your feet was constantly shifting and changing. Volcanoes dominated the landscape, spewing ash and rivers of molten lava, shaping a raw, dangerous planet. The sky was often darkened by thick clouds of ash, and the land was sculpted by relentless eruptions. The air was heavy and dense, filled with the scent of sulfur. The sun, struggling to break through the haze, cast an eerie orange glow over the land. The only sounds were the thunder of eruptions and the relentless crashing of waves against volcanic shores. Oceans stretched endlessly, vast and mysterious, bordered by jagged volcanic rocks and strange alien plants clinging to life at the water's edge. Life here was primitive, and every shoreline hinted at secrets waiting to be discovered. There were no birds in the sky, no familiar animals roaming the land, just the raw, untamed roar of nature itself, echoing across empty plains. This was the Permian period, a forgotten chapter in Earth's history, millions of years before the first dinosaurs would ever appear. We often focus on T-Rex and Stegosaurus, but these famous giants arrived late to Earth's story. The world before them was already teeming with life and drama. Before dinosaurs, other remarkable creatures ruled a single giant landmass called Pangaea, where continents were fused together and the climate was harsh and unpredictable. Their world was one of extremes, intense heat, violent storms, and endless possibility. Life had to adapt quickly or vanish forever. To truly understand this lost world, we must erase our modern maps and ideas and imagine a planet both familiar and utterly strange. Let's travel back over 250 million years, to an age of pioneering giants and evolutionary experiments, where the rules of life were still being written. This is the story of the world before the dinosaurs, a time of chaos, transformation, and the dawn of life as we know it. In the Permian period, over 250 million years ago, all the land on Earth was fused into a single massive supercontinent, Pangaea. Imagine a world where the familiar shapes of today's continents are gone, replaced by one vast, unbroken expanse of land. There was no Atlantic Ocean, no separate continents, just a single, colossal landmass stretching from the northernmost reaches to the southern pole, dominating the planet's surface. You could, in theory, walk from what's now Spain all the way to New York without ever needing to cross a sea or ocean. The land was continuous, a true bridge between worlds. The continents we know today were jammed together, their jagged edges fitting like pieces of a gigantic jigsaw puzzle, creating a landscape of epic proportions. Surrounding Pangaea was Panthalassa, a global ocean that covered nearly the entire rest of the planet, its waters stretching farther than any modern sea. Panthalassa's powerful currents and endless coastline shaped the climate, carving out new weather patterns and influencing the evolution of life itself. Deep in the center of Pangaea, far from any ocean, the land was parched and dry, creating vast deserts where few plants or animals could survive. Meanwhile, the coastal regions were battered by intense monsoons, soaked in humidity, and shaped by powerful seasonal winds that brought both life and destruction. This geography created a world of stark contrasts, scorching deserts at the core, lush forests and thriving ecosystems at the edges, where water was plentiful. With so much land connected, animals could migrate across entire continents, spreading species and mixing ecosystems in ways never seen before or since. Pangaea's unique setup set the stage for the strange and wonderful life of the Permian, from giant reptiles to bizarre plants, all adapting to this ever-changing world. The climate, weather, and evolution of life were all shaped by this supercontinent, driving both diversity and extinction on a scale never before witnessed. Welcome to a world where the rules of life were being rewritten, and the stage was set for the next great chapter in Earth's history. Pangaea's climate was extreme, vast deserts at its heart, humid jungles along its coasts. The interior was a scorching, arid wasteland, larger than any desert today. Only the toughest plants and animals survived in this relentless heat. In contrast, the coasts were drenched by powerful monsoons, feeding dense forests and swamps. No polar ice caps existed. Even the poles were mild and ice-free. Sea levels were higher, and the world was a greenhouse, hotter, wetter, and wilder. With no barriers, animals spread across the continent, creating a global community. Fossils of the same creatures are found today in places now separated by oceans. They didn't swim, they simply walked across Pangaea. This interconnectedness shaped evolution, making the Permian world a true melting pot. Life thrived in the extremes, adapting to a planet unlike anything we know. The world was their backyard. Step into a Permian forest, and you'd think you'd landed on another planet. The air is thick with moisture, and the landscape is unlike anything we know today. It's a world where time seems to stand still, and every corner is shrouded in mystery. No flowers, no grass, just mosses, ferns, and decaying plant matter underfoot. The ground is soft and spongy, layered with centuries of fallen leaves and ancient debris, creating a rich, earthy scent that fills the air. Giant ferns and horsetails formed dense, towering canopies, blocking sunlight and creating perpetual twilight. The forest is dim, with only scattered beams of light piercing through the thick foliage, casting shifting shadows on the ground below. Early conifers, ancestors of today's pines, added a sharp, resinous scent to the air. Their needle-like leaves and rough bark stood out among the softer greenery, hinting at the evolutionary changes to come. The forests were dark, humid, and mysterious. Water dripped constantly, and the air was thick and still. Every step echoed with the sounds of distant water and the quiet rustle of ancient plants. Plants reproduced without flowers, relying on spores, and for conifers, seeds and cones. This primitive method of reproduction was perfectly suited to the damp, shadowy world of the Permian. Ferns and horsetails released billions of spores carried by wind and water. These tiny particles drifted through the air and across the forest floor, ensuring the next generation of plants could take root almost anywhere. Conifer seeds were a major evolutionary leap, allowing them to thrive in drier areas. This adaptation gave them an edge as the climate shifted, helping them spread across vast stretches of land. The Permian forests were alien, lush, and vital to the planet's future. Their dense vegetation helped shape the atmosphere, locking away carbon and producing oxygen for the world's growing animal life. These ancient plants shaped the world, setting the stage for everything to come. Over millions of years, their remains would become the coal and fossil fuels that power our world today. The forests were both a refuge and a challenge for the creatures of Pangaea. They offered shelter and food, but also hid dangers and fierce competition for resources. Life here was a constant struggle for light, water, and survival. Only the most adaptable plants and animals could thrive in this ever-changing primeval world. Welcome to the green heart of the Permian, where the story of life on land truly began to unfold. Permian forests thrived in vast, swampy wetlands along Pangaea's coasts. Giant ferns and horsetails grew in abundance, their remains piling up in oxygen-poor waters. Without oxygen, dead plants didn't rot. They formed thick layers of peat. Over millions of years, these layers were buried, compressed, and transformed by heat and pressure. The result: coal, the black rock that fuels our world today. Every time we burn coal, we release energy captured by Permian plants 250 million years ago. The coal beds of North America, Europe, and Asia are the fossilized remains of these ancient forests. They're a direct link to the lost world of Pangaea. The story of coal is the story of life, death, and transformation on a planetary scale. The world before dinosaurs literally powers our modern lives. The legacy of the Permian forests endures every time we flip a switch. Before dinosaurs, the land was ruled by synapsids, our distant ancestors. Often called mammal-like reptiles, they were actually a separate branch, leading to mammals. The most famous synapsid, Dimetrodon, was a top predator with a sail on its back for temperature control. Synapsids came in many forms: small insect eaters, bulky herbivores like moskops, and fierce carnivores. They had differentiated teeth and more upright postures, making them efficient and adaptable. Some, like moskops, may have used their thick skulls for headbutting. Synapsids experimented with temperature control, hinting at the warm-bloodedness of future mammals. For millions of years, they were the dominant land animals, filling every ecological niche. They were the stars of the Permian, long before dinosaurs appeared. Their evolutionary innovations paved the way for mammals, and for us. The age of synapsids was a time of incredible diversity and success. While synapsids ruled the land, giant amphibians and insects thrived in the swamps and air. Amphibians like Archaeops, built like crocodiles, hunted in murky waters but needed moisture to survive. Their dependence on water kept them near coasts and rivers, where they were top predators. The Permian air was rich in oxygen, allowing insects to grow enormous. Dragonflies with seagull-sized wingspans zipped through the forests, hunting prey. Giant millipedes like Arthropleura crawled across the forest floor, feeding on decaying plants. Oversized cockroaches and spider-like creatures filled the undergrowth. These giants thrived in the dark, damp forests, shaping the ecosystem. For a time, the world belonged to these creepy, crawly titans. The Permian was an age of monsters, on land, in water, and in the air. It was a world both fascinating and fearsome. For millions of years, life on Pangaea thrived in a delicate balance. But deep within the earth, disaster was brewing. In Siberia, massive plumes of magma began to rise, triggering one of the largest volcanic events in history, the Siberian Traps. Fissures ripped open the land, unleashing rivers of lava for thousands of years. The sky darkened with ash, and the ground shook with constant eruptions. But the real danger was the release of greenhouse gases, carbon dioxide, methane, sulfur dioxide, into the atmosphere. These gases overwhelmed the planet's natural systems, breaking the balance of life. The stage was set for a catastrophe unlike any before. The world was about to face its greatest test. The storm was coming and life teetered on the edge. The Permian world was about to change forever. To truly grasp the scale of this event, you must forget everything you know about modern volcanoes. Even the most violent eruptions in recorded history pale in comparison. The Siberian Traps were not a single eruption, but a vast volcanic province that bled lava for nearly 1 million years, reshaping the face of the planet. Enough molten rock poured out to bury the entire United States under a kilometer of lava, an unimaginable volume stretching as far as the eye could see. Imagine an eruption 1,000 times more powerful than Tambora, the largest eruption in modern times, but instead of days or weeks, it raged on for millennia. The Siberian Traps were a planetary fever that refused to break, a relentless force that pushed Earth to its limits. Lava flooded the land in thick, fiery sheets, covering millions of square kilometers and transforming lush landscapes into barren wastelands. Each pulse of volcanic fury released a toxic cocktail of carbon dioxide, sulfur dioxide, and methane into the atmosphere, poisoning the air and sky. The lava incinerated everything in its path, while the gases launched a chemical assault on the globe, altering the very chemistry of the atmosphere and oceans. This was not a sudden disaster, but a slow, grinding apocalypse that unfolded over generations, giving life little chance to recover. The world didn't end with a single bang, but with 1 million bad days, an endless parade of darkness and despair. Greenhouse gases from the eruptions triggered runaway global warming, trapping heat and suffocating the planet. Temperatures soared on land and sea, pushing ecosystems to the brink and bleaching the oceans of life. The planet was being cooked alive, its surface scorched and its waters boiling, as if Earth itself was feverish and delirious. The slow, creeping nature of this catastrophe was its most terrifying aspect. There was no escape, only the relentless march of devastation. Life was brought to its knees, one relentless day at a time, as the world was transformed into a graveyard of lost potential. The true killers were the gases from the Siberian Traps. Carbon dioxide triggered a catastrophic greenhouse effect, raising global temperatures by as much as 10 degrees Celsius. The poles became temperate, the tropics turned deadly. Sulfur dioxide created acid rain, burning forests and poisoning rivers. Ecosystems collapsed as plants died and soils washed into toxic seas. The oceans, absorbing carbon dioxide, became acidic, dissolving the shells and skeletons of marine life. The foundation of the marine food web crumbled. As the seas warmed, oxygen levels plummeted. Vast stretches of the seafloor became anoxic, breeding toxic bacteria. These bacteria released hydrogen sulfide, killing marine life and possibly poisoning the land. The world was suffocating, poisoned from above and below. Life was under siege on every front. Picture the shoreline at the height of the Great Dying. The air reeks of sulfur, the sun a dim red orb behind choking haze. Silence reigns. No birds, no scuttling creatures, only the lapping of waves against beaches littered with death. The once teeming Permian oceans were emptied. Trilobites, ancient reef builders, and brachiopods vanished. Marine ecosystems built over eons were wiped out, leaving a ghost ocean. On land, forests withered under acid rain and heat. Erosion scarred the landscape, rivers ran thick with mud. Food webs collapsed, predators starved, herbivores found nothing to eat. The world became a wasteland, a planet of ghosts. The sounds of life were replaced by the whisper of wind across emptiness. Fungi thrived, feasting on the dead, evidence of a great rot after the Great Death. The planet was in mourning, shrouded in its own demise. Life's symphony had fallen silent. The Permian Triassic extinction was a cascade of catastrophes. Immense volcanism was the first domino, but it was the chain reaction that doomed the world. Greenhouse gases trapped heat, causing global temperatures to soar. Oceans lost oxygen, creating vast dead zones. Acid rain destroyed forests and poisoned waters. Ocean acidification dissolved marine life. Anoxia allowed toxic bacteria to thrive, releasing hydrogen sulfide that killed even more. Volcanism, warming, acidification, and anoxia, each disaster amplified the next, leaving life defenseless. The statistics of the Great Dying are staggering. Up to 96% of marine species vanished. Entire groups, trilobites, sea scorpions, ancient reefs, were wiped out. On land, about 70% of vertebrate species disappeared. The dominant synapsids, our distant ancestors, were decimated. Top predators and great herbivores vanished. Only the hardiest, smallest creatures survived in a hostile world. The world that emerged was a pale shadow of the Permian. For millions of years, life was sparse. Disaster taxa, hardy, opportunistic species, dominated. Lystrosaurus, a pig-sized synapsid, became the most common land vertebrate. Recovery was slow. Ecosystems took millions of years to rebuild. The seas remained stagnant, the lands barren. The Great Dying had cut the tree of life down to a stump. Evolution's reset button had been pressed. The old rulers were gone, their dynasties erased. The world was a blank slate, awaiting new life. Life is resilient, but recovery from the Great Dying was agonizingly slow. The planet remained harsh for millions of years, wild temperature swings, low oxygen, barren landscapes. Disaster taxa like Lystrosaurus survived on land. Simple bivalves and microbial mats dominated the seas. Complex ecosystems were gone, replaced by simplicity. It took 5 to 10 million years for diversity to return. The early Triassic was a planetary convalescence, but extinction opened up empty ecological niches. Survivors faced little competition and could experiment with new ways of life. Evolution began to innovate, filling roles left vacant by the old kings. Synapsids evolved into new forms, some leading to mammals, but reptiles, with their scaly skin and efficient metabolism, were especially suited to the new world. The stage was set for a major power shift. The animal kingdom was about to change forever. Before the Great Dying, reptiles were minor players in the ancient world, overshadowed by the dominant synapsids. They crept through the undergrowth, rarely rising to prominence, and played only a supporting role in the grand drama of life on Earth. The extinction changed everything. Synapsids were devastated, but reptiles proved resilient. As the dust settled, it was the reptiles who survived, their numbers growing while others vanished forever. Their water-conserving skin and heat tolerance gave them an edge in the harsh, dry, post-extinction world. These adaptations allowed them to thrive where others could not, enduring drought and searing heat. As the world recovered, reptiles diversified explosively, an adaptive radiation that saw them evolve into a dazzling array of forms, filling every corner of the recovering planet. They filled every available niche. Some became swift marine predators like ichthyosaurs, conquering the ancient seas and hunting with speed and precision. Others took to the air as pterosaurs, the first vertebrates to master flight, soaring above the land in search of prey and new territory. On land, archosaurs, ancestors of crocodiles, pterosaurs, and dinosaurs, rose to dominance. Armored etosaurs and crocodile-like phytosaurs patrolled the rivers and floodplains, each adapted to their own unique way of life. And massive rauisuchians ruled the Triassic, towering over their contemporaries as apex predators, shaping the food chains of their time. Dinosaurs were just one group among many, mostly small and bipedal. living in the shadows of their larger reptilian relatives, waiting for their moment. But they had key adaptations, efficient hips and legs for movement, allowing them to run swiftly and conserve energy, setting them apart from the rest. They were biding their time, honing traits for future dominance, quietly evolving the features that would one day make them rulers of the earth. The world had been cleared for reptiles, and they seized every opportunity, spreading into new environments and multiplying rapidly. The greatest of all reptiles were about to make their entrance, ready to leave an indelible mark on the planet's history. The age of reptiles had begun, but the age of dinosaurs was just over the horizon, waiting to transform the world forever. The stage was set for a new dynasty, one that would dominate the Earth for millions of years to come. Out of the Triassic crucible, a new kind of reptile emerged, the first dinosaurs. Unlike their sprawling relatives, dinosaurs had legs directly beneath their bodies, allowing efficient movement. Early dinosaurs like Neasosaurus and Eoraptor were small, nimble hunters. By the late Triassic, true dinosaurs were becoming more common, diversifying and recovering ecosystems. Their upright stance and likely higher metabolisms made them formidable competitors. As the Triassic ended, another extinction event cleared away many rivals. Dinosaurs weathered the storm and seized their chance. The dawn of the Jurassic marked their undisputed reign. They exploded in diversity, evolving into the giants we know today. Small predators gave rise to colossal carnivores like Allosaurus. Early plant eaters evolved into the massive sauropods. The Great Dying had paved the way for one of life's most spectacular creations, the dinosaurs. Their time had come,